Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the make the string great problem. Given a string S of lower and uppercase English letters, that sentence went absolutely nowhere. A good string is a string which doesn't have two adjacent characters, si and si plus 1, where I is, well, obviously I can't be the very last thing because then there's nothing following it. If si is a lowercase and si is the same letter uppercased, that's bad. We need to get rid of that. To make the string good, you can choose two adjacent characters that make the string bad and remove them. You can keep doing this until the string becomes good. Return the string after making it good. The answer is guaranteed to be unique under the given constraints. Notice that an empty string is also good. Okay, so here, for example, well, let's do the first one first. Leetcode with too many E's. We see this EE business or this EE business. They need to go. So if we get rid of those, we end up just with the word Leetcode. This one here, this BB and CC are bad, so we remove those. But once we've done that, we have the AA next to each other. That's also bad. That needs to go. So we end up with the empty string. S by itself is absolutely fine. Constraints, S is not going to be terribly long. So I think one thing to be wary of with this problem is that your gut instinct is going to be something like, okay, I'll go through and I'll remove all the bad cases. But you can introduce a bad case when you're doing that, so you just kind of need to keep removing bad cases until you until you've stopped making changes, basically. The technical term for that is you've reached a fixed point. So if you call make or make good partially on a string and you get back that string itself, you've reached a fixed point. Formally, a fixed point is when fx is equal to x. So you could just iterate like that. But that could be very, very slow because you don't necessarily know when you're going to get there, and it might take a very long time to get there. And that also means you're doing a lot of shuffling around with your string. But this kind of problem, where you tend to always be looking at something and its successor, this is a kind of problem that's very amenable to a stack. So if you've not seen a stack before, stack is a data structure. It's like a stack of pancakes. I'm going to have a sideways stack of pancakes, but basically if I have a plate here and I put a pancake on it, all I can do is keep putting pancakes on top. I can't go somewhere in the middle and try and insert a pancake into the stack. That doesn't work very well. So a stack just lets you look at the thing on top. And that's enough when we're only looking at the thing on top and the thing we're about to put on. So if I have my plate of pancakes, I put the first letter on, and then I look at the next thing and decide whether, well, I can do two things. I can either add this pancake to the top of my stack and keep going, or I could take the current top pancake off. I could eat the top pancake, and I get back an empty plate. And then I can put the new pancake on, or I could have eaten that as well. It doesn't matter. The point is we can only access the very top thing in our stack of pancakes. Now, I think that is the trick to this problem. Because if I go and see L in my stack, I put L on first. Then I look at E, and I look at the L that's already on my stack. L and E are different. There's absolutely nothing wrong here. So the E goes on. Then I see a capital E. Now, if I put the capital E on, all I've done is reintroduce a case that's bad. So I don't want to do that. What I want to do is I want to not put the capital E on, And even more, I want to undo putting that first E on. I'm going to eat the pancake on the top of the stack. So now we've dealt with the L, the E, the big E. I see a lowercase e again, so I put that on because I'm looking at the L and E don't conflict in any way. I see another E, and I'm going to put that on because the lowercase e's don't mismatch. I'm going to see the T, the C, the O, and the D. None of those are going to be the same letter in different cases. And we get to the end with our Leetcode. If we have a go with this second one here, I'm going to put the A on, I'm going to put the B on, and then I see the big B, and if I put that on, I've reintroduced a mistake. So I take both of them off. I eat both of the pancakes. I then go to put an A on, but lo and behold, that would also introduce a mistake. So I don't want to do that either. I need to eat both of those pancakes. I put the C on, and then if I go to put the capital C on, again, that's a problem. So I take them both off, and I'm done. The final case, put the S on, we're done. So the result of all of this is going to be, in fact, let's call it very explicitly, a stack. I am making a stack. Then I'm going to do stack.append S0. The first thing we always put on no matter what. And then for car in S, everything after the first one, this is where we need to do our checks. If the thing on the top of the stack, lowercased, is equal to the character, lowercased, and they're not literally equal. So here, this is saying, are they the same letter? So E and E are the same, and they're not exactly the same. So these two lowercase e's aren't in conflict, for example, but a lowercase and an uppercase, or an uppercase and a lowercase, they would be in conflict. So this is our bad case. This is where we need to, well, first off, don't append, but we also need to eat the pancake on the top of the stack. Pop it off. If that's not the case, there's no conflict. We can just put the next pancake, the next character, onto our stack. We need to give back a string here. So this is a Python type annotation. It says we're given a string and we need to return a string. I've got a stack, a list, so I just need to turn that back into a string. I think it's probably worth seeing the stack and the character both before and after we try and do anything. So we see the L goes on the stack. We see the E, we're doing a comparison, and it's fine to put on. We see the capital E, and that means we don't want to put the capital E on, and we want to take that lowercase e off. But then we're on the happy path and can just continue to work our way all the way down. Let's do it with all of the example test cases. Oh. So I had a bug. The bug here, it's saying I've got an index out of range, and the only indexing I'm doing here is trying to read the last thing in the stack. Now, what I could do is do if the length of the stack is greater than 0 or something like that, but Python has this handy little trick where you can go if the stack, just if the stack. And what this does is it returns true if the stack is non-empty. So if the stack has something in it, and then we do the rest of our check. Now, ands in Python are short-circuiting, and what that means is if this fails, it won't even bother trying any of this. So if the stack is empty, we're just immediately in this case here. Otherwise, if the stack has something in it, then we need to do the rest of our check. If that doesn't make sense, feel free to write it out longhand, but that's sort of idiomatic Python. This is something you'll see in lots of Python code. So down here, if we're doing our A, B, B, A, C, C, we see the A is already on, we put the B on, no problem. We go to put the capital B on, problem, we get rid of both of them. We go to put the capital A on, problem. So we take both of them off. C goes fine, capital C, that would cause a problem, so we take them both off. And then finally for the S, well, we didn't get far enough through. We didn't get far enough through to even start showing the stack because there's nothing in this substring. Right, we can turn off our printing now. I'm convinced this works, and we can submit it. Fantastic. Again, these numbers are fairly meaningless if you've seen any other videos. If you submit exactly the same code and it's sort of running in these kind of time frames, it's just going to randomly generate a number basically, which is not terribly helpful. This is quite a nice little problem. Gets you thinking about stacks. There's sort of a couple of fundamental data structures that you always need to know. Stacks are one of the big ones. They come paired with queues quite a lot. Interestingly, Python lists are very good at being stacks and they're very bad at being queues. If you've not thought about that before, do ever think about why that might be. So yeah, that was the make the string great problem. I have no idea what I'm going to make the thumbnail for this video, particularly today, given all of our stateside friends are busy being political. But that's a problem I now have to try and work out. Anyway, do remember to like, comment, subscribe, all of that good stuff. In particular, do let me know how you got on, how you tackled this problem. Did you have a go at the fixed point solution, or did you try something else entirely different? Do let me know. Other than that, I will see you next time. Bye.